Okay, good morning. Welcome back to my YouTube channel. Again, this is Santos Capellan Jr. wishing you a good day. Now, as I promised, I will try to complete my BMS graphics for twin exhaust fan. Now, to make it more professional looking, I have completed it. I have put some animation. Like if the fans are running, there will be some animation like this arrow. It will show the direction, how the fumes from the battery charger room will be vented out. Okay. Now, last tutorial, I have completed the physical points. So when I say physical points, these are the physical points, BMS points associated with cable or wire. Okay. Now, meaning from control panel of the exhaust fan, we will be providing these physical points like auto status, start command, run status, airflow. Airflow is coming from the differential pressure switch coming from this one. Okay, as you can see here, this is the differential pressure switch installed across the fan. So we will be getting one physical point from this one, that is the airflow status. Then trip status coming from the overload protection of the motor. Okay, so these are the physical points. Physical points are associated with physical wires. Okay, now meaning from control panel, we will be pulling cables going to our DDC panel. So those are the physical points when there is cable. Now, here I already provided the software points. Now, the software points are the one that will be generated in our control logic program. Okay, now next tutorial will be our control logic programming using functional block diagram programming. Okay, so it is more exciting than the graphics, but I guess for new BMS engineer, everything is exciting. Okay, now here, what are the software points that I provided here? Okay, now EF1 runtime alarm. Now runtime alarm, these are being used for maintenance purposes. Now, as you can see here, I have here runtime set point. Now, if I am the facility management, I will facility management engineer, I will specify, okay, if these two fans run, let's say EF1 are already working for 500 hours. As you can see here, I have a set point, okay, 500 hours, then that's the time to do some maintenance work. Let's say if this is belt driven, then we need to check the belt. If it is still tight, maybe it's already loose or the belt are cracked, then it's the time to change the belt. Now, this runtime set point is flexible. I made it flexible so that the BMS operator, upon the request of the upon the request of the maintenance engineer, he can change the set point. Maybe the engineer will say, okay, 500 hours is too short. Let's make it 1,000. Okay, so he can adjust it in the BMS graphics. Okay, so I provided the increase and decrease button so that it is easy to change the runtime set point. Likewise, I have here EF1, EF2 sequence set point. Now, EF1 sequence set point, this is the changeover. Maybe after 168 hours, this is 1 week, then the standby fan will run. Then vice versa, it will keep on changing over from EF1 to EF2. The purpose of this is for equal wear and tear of the equipment, okay? Because we don't want EF1 will always be running, then EF2 will just run when EF1 trips. So to provide equal wear and tear, that is good engineering practice for the equipment, we are doing the sequencing or changeover, okay? So EF1 run hours, we will be displaying here. Okay, so how long this EF1 is running, then EF1 runtime reset. Okay, this EF1 run hours will be related to the runtime set point. Okay, now EF time runtime reset. Okay, so because if the runtime set point is already reached, the control program will generate an alarm. Okay, so this maintenance alarm will be showing alarm. Okay, so runtime reset, if you want to reset the runtime hours back to 0. Okay, now EF1 airflow alarm. Let's say EF1 airflow alarm, I have given the command to the fan to start. Then after some time delay, I did not receive the airflow status, meaning this airflow alarm will be raised by our control logic program. Then the BMS operator will be notified or prompted that he needs to call the maintenance people to check the belt or the motor for the said exhaust fan. Then EF1 alarm reset. Okay, so if the alarm is already cleared in the field, then the operator can reset it. Okay, now EF1 runtime sequence. Now, this runtime sequence is related to this sequence set point. So you will see, okay, if the fan is already running 167 hours, within 1 hour, EF2 should be running. Okay, then after each changeover, then the runtime sequence hours will be reset back to 0. Okay, so these are the software points that we are going to define and generate in our control logic program. So for the BMS graphics, there will be software points. As you can see here, EF1 runtime alarm, run hours, runtime reset, maintenance alarm, airflow alarm, alarm reset, runtime sequence, then set point for sequencing, then set point for runtime. Okay, likewise, the same points for EF2. So this is the complete graphics for this twin exhaust fan battery charger with animation and with software point. Now, in my next tutorial, I will be starting the control logic programming. I hope I have given you the enough information for how are you going to test and prepare your BMS graphics. It's just a simple BMS graphics because some engineering tool of other solution provider, they have 3D graphics. But the concept in creating your graphics and testing it is almost the same for almost all engineering tool of solution provider company like Honeywell, Siemens, Allerton, Delta Control, and so many control company. Okay, now again, I hope I have given you the complete idea for BMS graphics, how to test it offline, okay, how to provide some this animation, and how are you going to provide the software points and physical points for the said equipment. Once again, thank you very much for watching this short video clip. And if you are new to my channel, you can always subscribe, and you can also click the notification bell. And I wish you could leave a comment so I can still improve what I'm trying to teach you and what I'm trying to share. Then I'm not claiming any expertise here. I'm just sharing my experience gained in my several projects for building management system. Once again, Santos Capilla Jr. saying God bless us all and bye for now.